Number 9. A string with a linear density, and they're giving it 8 grams per meter, but it has to be converted to kilograms per meter, right? We need the proper units. So we're going to go, so linear density is mu, and it's 0.008 kilograms per meter is under tension. So the tension force is 200 newtons. And they want to know what's the speed of the wave. Well, we have our equation that velocity equals the square root of tension over linear density. So it's just a matter of plugging in our numbers. 200 is the tension, and the linear density is 0.008. And our calculator tells us it's 158 meters per second. Number 10. A wave speed in a piano string of linear density. Again, that linear density is mu, and it's 0.005 kilograms per meter. And they're giving us this time, they're giving us the tension, or the speed, which is 140 meters per second. What's the tension? And remember, it's a force, so the units are newtons. We have our equation, velocity equals the square root of tension over linear density. And we want to isolate force of tension. So to get, before we even look at the numbers, let's isolate what we're looking for. So to get rid of the radical sign, we have to square both sides. So that leaves us with v squared equals ft over linear density. Now to get tension by its support, by itself, we have to multiply both sides by mu. So we're going to come up with tension equals v squared times mu. Now that we have tension by itself, tension is all by itself, now we can plug in our numbers. So velocity is 140, and remember, that needs to be squared. And then we have to multiply that by mu, linear density, 0.005. And when we work out those numbers on our calculator, we get 98 newtons. Number 11. A wire with a linear density, that's mu, 0.015 kilograms per meter, undergoes a tension force, so they're giving us the tension force of 250 newtons. A transverse wave with a wavelength of 0.40 meters is produced in the wire. What is the wave speed? And what is the frequency? Bunch of questions here. All right, so we can say velocity equals square root of tension over mu. And the first thing we want to solve for is our velocity. Our tension they gave us was 250. And mu is 0.015. And when you solve for velocity, we're getting 129 meters per second. All right, so that gives us velocity. But now we need frequency. Well, we go back to our other equation. Velocity equals lambda f. And we can solve for frequency by isolating f. Frequency equals velocity over lambda. Divide both sides by lambda. Now plug in our values. The velocity we figured above was 129. And we're going to divide that by our wavelength, which is 0.4, and we're getting a frequency equal to 322.5 hertz.